All right, let's go ahead and take a look at 8.1, systems of equations. This is a lot of review because you should have seen this before, but it does show up in our curriculum. So if we take a look, if we look at what a system of linear equations is, it is a collection. Oop, my pen working here. Of two or more linear equations involving the same variables. Okay, so the solution to a linear system is going to be the solution is a solution that satisfies all the equations. So when you get your answer, you should be able to plug it back into all the equations and it works. So typically when you take a look at this, you look at it graphically first. So y equals 2/3 x minus 4 and y equals negative x plus 6. This is an easy one to graph because it's already in slope-intercept form. So our first graph here, we've got a y-intercept of -4. And then we're going to go up 2 over 3, up 2 over 3, up 2 over 3, down 2, left 3, etc. So there's my first line, my first linear equation. My second one, if we go ahead and we graph that, negative x plus 6, a y-intercept at 6, down 1 over 1. And if you continue that pattern all the way through, you see where they intersect. So that is going to be their solution, where they intersect here. So that intersection point is located at 6, 0. If you plugged into this equation to check 6 for x, you would get 2/3 times 6, which is 4, minus 4, which gets you 0. So it does work. You could also plug it into the second equation, -6 plus 6, that gives you 0. So it satisfies both equations. So graphically, at this point, if you were in class, I'd be having you do the next two problems. But I will go ahead and take a look. So the first one, notice that it is in point slope form. So this is going to be the point 4, -3 with a slope of 3/5. So 4, -3 and a slope of 3/5. There's my first equation. Now my second one, if I take a look, it is in, I can't find the intercepts very easily because -3x equals 10 gives me a messy number. So instead, I'm going to go ahead and solve for y. I'm going to add 3x. And I'm going to divide by 5. So I'm going to get a slope of 3/5 and a y-intercept of 2. Oh, something interesting is happening, and maybe you're seeing it too. That these slopes happen to be the same. So what happened when we graphed this, there was no solution. They do not intersect at all. So these lines are parallel, which means slopes are the same, but different y-intercepts. And there's no solution. Okay, go ahead and take a look at the third one. Same idea. We're going to go ahead and graph this. This would be the point -4, 1, because it's in point slope form with a slope of -2. So -4, 1 with a slope of -2. Looks like this. I'm going to go ahead and make my line. The next one I'm noticing has slope-intercept form, easy to graph, a y-intercept of -7 and a slope of 2. Oops, I am noticing I did not graph that line right because -4, 1 is here. There we go. I was noticing something is wrong. -4, 1 is right here. I graphed -4, -1. Okay, now that line looks good. Now when I graph my other line, I have a y-intercept of -7 and my slope is down 2/1. And this is what should have happened is these graphs happen to be exactly on top of each other. So we would call that infinitely many solutions. Every single point on the line is a solution. Not all solutions, it's not every coordinate point, it's only the points that are on the line. So this is when they have the same line, which means they have the same slope and the same y-intercept. So you can call this IMS for short. Okay, so that's graphically how to solve. So the options that you could have are, for your solutions, exactly one. If you have exactly one solution, that means you're going to have different slopes. Could have the same y-intercept, could not, doesn't matter. You have infinitely many, you have two lines that are on top of each other, so that would be the same slope and the same y-intercept. No solution would be the same slope and a different y-intercept. And those would be parallel. Okay. Now, let's go ahead and solve by the other two methods. We've got substitution and elimination. And if we tell you to solve it a specific way, you do need to solve it that way. So, first of all, for substitution, you want to make sure that your x's are lined up. Or no, sorry, that was elimination. For substitution, it's easiest to kind of solve when you have just a variable where you don't have to do any division or there's going to be messy fractions. So we just have a y. The coefficient in front is 1. That's perfect. So I'm going to go ahead and isolate this y. That's my first step. So for substitution, I'm going to isolate one of the variables. So all I have to do is subtract 4x and that y is isolated. Then what I do is I take equation 1 and I'm going to plug it into equation 2. So y goes out and -4x plus 1 comes in. So y goes out and -4x plus 1 goes in. So now I'm solving an equation with only one variable in it. So -2 times 4x is plus 8x. So I'm distributing here, combining my like terms, adding 2 over, dividing by 11, and x is 2. Not my final answer, part of my answer. Now that x is 2, I'm going to take that and plug it back into really any of the equations, 1, 2, or 3. But the easiest one to plug it into is the one I already boxed. So I can now say y equals -4. X is really 2 plus 1. That gives me a -7. So my final answer is the point 2, -7. So that's where they intersect. Again, you could plug that in and you would notice into both equations, it does in fact work. So that's substitution. So at this point, I would have you go ahead and try number 7. So again, for substitution, this one is nice. And I would try it by yourself, but if you want to listen, you can go ahead. I would fast forward and see if you get the answer correct. But y is already by itself, so you can quickly just go ahead and sub this in. So this is like saying 4x minus 8, y comes out, and half x plus 5 comes in, and it equals 24. So I distribute here. And something interesting is happening. 4x minus 4 is gone, and I'm left with -40 equals 24. Just like other equations, when that happens, it's not true. So this is a no solution. These must be parallel lines. All right, let's take a look at solving by elimination. So I'm going to go back up to number 5. Solving by elimination. You want your x's to be lined up, you want your y's to be lined up, and you want it to equal your coefficients, okay? And what you're trying to do is knock out either the x's or the y's by multiplying by something. So for instance, I'm going to go ahead and multiply this top by, if I want the x's to knock out, let's say 20. So I'm going to do times this by 4. And you have to multiply by 4 to everything. And that's going to give me a 20x minus 28y equals negative 44. And then I'm going to multiply the bottom one by a negative 5 because I want to knock out the x's. So I want them to be the same, but opposites. 4 times negative 5 is negative 20x. So notice those are the same numbers, but opposites. And then I've got a negative 15y. And then I've got 17 times 5, negative 85. Now, the reason you're going to do that is because now you're going to add down. And when you add down, the negative 20x and 20x cancel. Negative 28 minus 15 is negative 43y. The other two, when I add them, 85 is negative 129. And as I solve for y now, because now I only have one variable, I divide by negative 43, and y is a nice 3. Just like with the other question substitution, if y is 3, you can go back and plug it into any of your equations. We have 2 right here. Doesn't matter which one, I'm just going to plug it into the bottom one. So 4x plus 3, y comes out and 3 comes in, which gives me a plus 9 equals 17. I'm going to subtract 9 to get 8, and x is 2. So my final answer is 2, 3. Again, I could take 2, 3 and plug it into both equations, and I will get two equations that it would work with. Okay, I would go ahead and try number 6 right now if I were you, or if you need a little bit of help to go ahead and listen. The easiest way for this one would be to knock out your x's again, because I just have to knock out, or I just have to multiply the top by a negative 3. Otherwise, if I try to knock out the y's, I'd have to multiply both of them by a number. So this is negative 3x minus 15y equals 27. My bottom equation I'm going to keep. I'm doing nothing with it. I'm going to go ahead and add down. So this knocks out. Negative 15y minus 6y is negative 21y. And that's going to equal a positive 21. I'm going to divide by negative 21, and y is negative 1. Great. Go back and plug it into either equation. I'm going to plug it into the top. So I'm going to say x plus 5 times negative 1 equals negative 9. So x minus 5 equals negative 9. Add 5, and x is negative 4. So my final answer is the point negative 4, negative 1. Okay, last one is your choice. You can do whatever you'd like. For me, I think I'm going to go ahead and solve for y. I think I'm going to use substitution, but either method would be fine. If you were going to do elimination, again, you would need the x's to be lined up, which they are not currently. You'd have to subtract 2x. Or you could just switch this side and this side. That would work as well. Actually, maybe I'll do elimination. Okay, so we've got 10x minus 5y equals 30. I'm going to go ahead and say this 2x minus y. I'm just going to switch the sides, and it equals 6, and it's lined up. That's why I decided to change my mind. So I'm just going to go ahead and multiply this bottom one if I want to knock out the y's by 5. Again, not the only way to do this. You could do substitution. Once you go ahead and I multiply that, my top equation is still 10x minus 5y equals 30, doing nothing to it. My bottom equation, I want to multiply by a negative 5 to knock it out. That's going to give me negative 10x. And that's going to give me a plus 5y, and that gets me a negative 30. So now I'm going to go ahead and add down negative 10x and a 10x. That gives me 0. A negative 5y and a 5y is 0. And a 30 plus a negative 30 is a 0. Notice this is a true solution. This works. 0 equals 0. That is true. So this is going to be infinitely many solutions. Notice this one was a false statement. These were not equal. Notice this one is equal. So it is infinitely many solutions. All right, that is it on your review of solving systems of equations.